Welcome to a quick tutorial on plot360EX, and I'm using 2014 R2. This tutorial is going to be in two parts. First is going to be loading and working plot3d files. The second piece will be using some of the new context toolbar options to control style for objects on screen as well as slice isosurfaces. So let's get started. If you go to the file load dialog, we've actually consolidated this so that any of our existing loaders are accessible as well as loading layouts. In this case we are going to use plot3d. If I want to get back to existing capabilities in our legacy product, you can hit advanced options and open, and that will bring up the plot3d file loader. In this case, however, we're just going to leverage some of the improvements, and I'm going to grab, say, maybe 20 or so solution files. I will also add the grid file, and then I'll open all of these. Now, in the past I would have had to go specify some additional options, but in this case I don't need to do that. You'll notice there's nothing on screen. If I turn on a bounding box, you can see that in fact what we've done is we've loaded in those volume cells. However, those blocks, we have not identified the surfaces of interest. And as a result, we have just a simple bounding box which helps show the extent of the domain. To see what's going on within this solution, we're going to turn on surfaces. I don't need the bounding box. I will open up the Zone Styles dialog, and when it's under Surfaces, which is about the 9th tab over, surfaces to plot is currently set to none, which is common. Any data that we bring in that's volume only, we will set it to none. You as a user will then have the opportunity to say, I want to look at the J-planes. Once we do that, you can see that in fact we have a series of objects. These particular surfaces aren't necessary. They're just part of a multi-block solution, so we will hide them. So I can just select and hit hide, and we should be able to get to just the cylinder. So this is the cylinder. This is a simple example. Let's flow over a cylinder. We're looking at vortex shedding in general, and you can see that those surfaces now are available here. Now, a couple things to point out is you can actually select by holding Shift multiple zones, and from there you can say, I want to see the contour, and so we can turn on, say, density in this case. So you can do this on a zone by zone basis, or you can select all the zones and do that as well, but in this case it's not overly important. We'll just leave that alone for a moment. If I right click on any zone surface, you can see that I have access to most of the zone layers that typically you would access through the Zone Styles dialog. So I can turn on a mesh, I can color that mesh by a variable if I chose to, I can use contour, I can also turn contour off. These are buttons. I can look at shade, so in this case the shade is currently set to white, but I could send it to, say, a different color, and then perhaps if I turn off the mesh you can see that the color is updated. If I wanted to make it translucent, I can control the level of translucency again very quickly from the toolbar. So the intent was to make it so that you can set surfaces or set surface properties very quickly without having to go to the Zone Styles dialog. And effectively what this does, as you can see here, is it actually is turning on and off the different attributes of the zone. And you could do this in a different way as well. So if you wanted to go in and add them individually, one could do that as well. But that's really not what the purpose of this exercise is necessarily, so we can go back and hide this guy. The intent here is to just show you some of those capabilities. Okay. Alright, so we have a contour on the cylinder. And what I'd like to do at this point is look at the fluid domain by dropping in a slice. So we'll drop in a slice. Slice is going to show row. That's effectively the fourth variable. If we go over to contour details, you'll notice that our contour group 1, which is what it's using, is in fact set to row. But I could actually look at the U component of velocity if I chose. And we can also change the orientation of the slice. The slice is currently in the X direction. If I want to look at a Y slice, I can type Y and it will move it into the Y axis, or Z if I want to look at the Z axis. So you can use, just very quickly, you can use the right click and some of the keyboard to set where the actual slice is going to be. So a Z slice is most appropriate for this example. We are going to move that slice, say, just to take a quick look at the domain. And since we're quite interested in vortex shedding in this context, we will calculate an additional variable, and that variable will be vorticity magnitude. Now, it's currently set up to calculate on demand. I'm going to remove that. These data are relatively small, so I'm going to go ahead and pay the tax, so to speak, by looking at those calculations more quickly. And so when I calculate here, it's actually going to calculate it for the complete domain. Again, with small data, this isn't much of an issue. If you have large data on, let's say you're looking at 100 million cells, if you use calculate on demand, TechPlot will defer calculation of vorticity magnitude until such time that you've actually had an opportunity to use it. And so that just speeds up your analysis. Of course, if you're doing an animation, it would be a little slower, as each individual time step, as it marches forward, would start that calculation for vorticity magnitude. So you can see it's about 57–58% of the way done. Mind you, I think we're looking at maybe 30 or 40 time steps, so it's actually going through time now. Again, if you want to defer that calculation, use calculate on demand. Okay, so as this finishes up, I'm going to show you a couple of things on how you can control contours and actually show those contours on screen. So as this finishes up, it should be okay. Looks like it's all done. Close this. We can go over to our slice group here, and you can see we can control attributes on that slice group. And if you go to the contour variables, you'll notice that the contour variable hasn't been set up yet. So we'll go into contour variable 8, put it to vorticity magnitude. You can see that the levels that it chose are relatively high, because there's usually an area of relatively high vorticity. So I'm going to set these between 0 and 250, and for simplicity, let's do 25 levels, and OK. We'll then go in and set the slice to contour on vorticity magnitude. Also, for this context, I don't need the legend, so I'll go ahead and hide both of these. Okay. Now, I can't see, in this case, I can't see on the other side of the slice, so I may, in fact, want to turn on some translucency just to get a better sense of where we are in space. I will then move the slice down a bit to the center of the domain, to about here. And if I hit play, you can actually go through and look at that animation. So we'll actually go through the different time steps. Another way that we might want to look at this is through an isosurface. And so through an isosurface, perhaps the easiest way to do that would be to go ahead and turn on isosurfaces, which we'll do here. The isosurface is set currently to row. We're going to set that to vorticity magnitude and set a value of, say, 150. It's a reasonable value. And then we'll just redraw. Okay, so there is my isosurface. And for this slice, if I don't want to see that slice, I can just hide it. So now we just have the isosurface itself. And so if I do a quick animation, you can kind of see the vortex shedding off the cylinder. As with other attributes in TechPlot, a right click on the isosurface allows me to do things like turn on a mesh. I can turn off the contour, for example, maybe use shade, make it yellow, and make it translucent. So all the things that you might want to control from an attribute of the derived object can be done directly from the main interface. All of that same capability is available via the dialog as well, so you haven't lost anything. It's just perhaps a little easier to get to the style of interest without having to go through the dialog. Again, you can animate through, and you can see how those, or look at the shape of the vortex structure coming off the cylinder. So hopefully that gave you a couple of ideas on how you might use TechPlot360EX to explore results from, in this case, plot3d. One thing I didn't mention that I will in a tutorial that will be around overset grid types is that we do have the blanking capability, and so if this data set included an iBlank variable, which it does not, we could take advantage of that iBlank variable to blank out parts of the mesh so that when you're doing additional analysis you're not double counting. But in this case it's unnecessary. Thanks for watching, and look forward to the next step in the process. We'll be going through working with large data for a similar exercise and setting plot style.